This is section 8.1, part 2. So in the last video, I was saying that this one right here was more energetic than the sine of x. So sine of 2x is more energetic than the sine of x. So if b is less than 1, like over here, it says b less than 1, we're going to have a horizontal stretch. Okay, so over here is b less than 1. Know how we get out to 2 pi, and it hasn't even completed one fundamental cycle. Okay, it needs to keep going to complete this fundamental cycle. So it's stretched out longer. Okay, now the amplitude, that is the A part of the general form. It's over here. So right now we're looking at A. So A is the amplitude, and it is affected by the y values. Okay. Okay, so it is the vertical stretch factor. So amplitude is the absolute value of A. If the absolute value of A is 1, then greater than 1, we have a stretch. If the absolute value of A is less than 1, we have a compression. And if it's equal to 1, then we just say neither stretch or compressed. It didn't do anything. Okay, so if we have a sine of, 1 sine of x, so here RA is equal to 1. So we have neither a compression or a stretch. And that would be this right here. Here is A is equal to 1. Okay, so nothing has happened with the vertical stretch factor. Now when I have, let's go out to 3 sine of x. So it is greater than 1, so we'll have a stretch. So greater than 1, so it'll be stretched out. So notice here, right here, it is higher and lower than our original function. Okay, now if it was compressed, so say we had f of x is equal to 1/2 sine of x. Well, that means that it'd be half of the height of our original 1 sine x. So it would be somewhere like right in here. It'd be right below our original function. Okay? Now your phase shift of a function. So you need the formula C over B. And back at our general formulas, remember we can write this two ways. Here's your C right here, here's your B. Or if you factor out a B, like you do here, then there's your C over B. That is your phase shift. Now remember, we have a negative right here. That's going to be important for the phase shift. And everything I'm pointing to for sine is also true for cosine. Okay, now if C is less than 0, it is going to shift to the left. If it is greater than 0, you shift to the right. If it's equal to 0, you don't have any phase shift. Okay, so if we look at sine of x, so here our C is just 0, so we don't have any type of phase shift. So here's our original function right here. Now if we have x minus pi over 4, so here pi over 4 is greater than 0, so it will shift to the right. Okay, greater than 0, it will shift to the right. Notice how, if we look at this point right here, let me erase this. If we look at this point right here, it has scooted over, and actually let me draw. This right here is our next function that we're talking about. Okay, and it has scooted over to the right. pi over 4 units. The next one is c is equal to pi, which is also greater than 0. So it's also going to scoot over to the right. Okay, so here's our function right here. Notice now at this point it went from right here to now right here. Again, it went to the right. Now if we had something like, say we had sine of x plus, we'll just say 5. Now how else I could write this? Notice I've got a plus right here. I need a negative because that's in our general form. Minus a negative 5, because a negative times a negative will give us a positive, and now I have my negative for my general form. So now look, our c is a negative. So what it's going to do is going to scoot to the left. So it'll be somewhere, oops, it'll start somewhere over here, okay? Somewhere over here. So now the original form was right here, now it has gone to the left over here. Okay, so your phase shift is your horizontal displacement. You'll move it to the left or to the right. Okay, now if we look at vertical shift, so now this is your letter D. So D was at the very end of our general form. Okay, so right here. So this is going to be our vertical shift. It'll move the graph up and down. Okay, so A was our vertical stretch. It'll either pull and stretch out your graph vertically, or it will smush it together and make it shorter vertically. C over B, or C divided by B, over here, that's going to make your graph move to the left or to the right. Now, a key thing to remember with whether you go to the left or to the right with your phase shift, if you've got a function like y is equal to 4 sine of, say, x plus 5, if this is a plus, you would think it goes to the right because it's a plus sign, but actually it'll go to the left because what you'd have to do is write it as negative or minus negative 5. So y is equal to 4 sine of x minus negative 5. So this makes this a negative, which means you've got to go to the left. Okay? Whereas if this is written as a negative 5 to begin with, well, I've already got my negative there. So we could write it as this right here. Notice that my C is a positive, so we would actually go to the right. Okay? So I see it as a negative. I would want to go to the left, but for the phase shift, it's actually opposite. You would want to go to the right. So I hope that wasn't confusing. If it is, just send me an email and we can talk about that more. Okay, so D, your vertical shift. If D is greater than 0, it's going to go, your graph is going to go upwards. If it's less than 0, it's going to go down. Equal to 0, it's going to stay right where it is. It won't go up or down. So like this. Here's our sine function before we do anything to it. If we add 2 to the end of our sine function, well, it's going to scoot your graph up by 2 units. If we have sine minus 2, it's going to scoot your graph down to 2 units. That's it on that one. Okay, now if we look at this graph right here, 3 sine of 2x plus 1, we want to go through everything we can about this graph. So your amplitude, remember that is A, and A is at the very beginning, so y, I'll write the general form. Here's our general form. So here's our A. That's our vertical shift, or our amplitude. That is the absolute value of A. Okay, so we've put absolute values around this. Absolute value 3 is just 3. So that's our vertical stretching. Notice that I don't have a plus or minus any number. I just have a B in front of that X value. Okay, So you could write this as y is equal to 3 sine of 2x plus 0 plus 1. This right here would be your c value, since there's no number there. And your phase shift is, shift is c over b. Well, this would be 0 over 2 or 0 for your horizontal shifting. Okay, period is 2 pi over the absolute value of b. So the absolute value of 2 is just 2. 2 pi over 2, well, the 2's cancel out and I just get pi. So that's the period for this function. And then last but not least, at the very end, this plus 1, that is your vertical shifting, and it's going to go up. Okay, we'll do the same thing here. Since I don't have a number, it's understood to be 1, so that's our amplitude. So since it's 1, there's no vertical stretching or compression. Now notice here, what is our sign? It's a plus, okay? Which means that our phase shift needs to be negative. If we had y is equal to sine of x minus pi over 6 minus 2, our phase shift would be pi over 6 because I already have that negative there. This I have to write as sine of x minus negative pi over 6 minus 2. There's your c value right there, or your phase shift. Now, notice I don't have a number in front of x. It's actually understood to be, I do have a number, it's just understood to be 1. So our c over b for our phase shift would be negative pi over 6 over 1, so just negative pi over 6. So what we have here is we're shifting to the left right here. If we just look at the original function, because it's positive, I would think it'd go to the right, but since it's talking about phase shift, it's the opposite, so we're going to the left. Or you can look at the phase shift after you already find it and say, hey, it's negative, we need to go to the left. Either way works. Okay, so since b is just 1, then that means period, which is 2 pi over the absolute value of b, since that's going to be 1, then our period is just 2 pi. So we have no horizontal stretching or compression. And then the last number, that negative 2, sometimes it's at the very beginning. Okay, so it doesn't always have to be the last number for your vertical shift. Since it's negative, that means we're going down with our graph. Okay, if we look at this one right here, our amplitude is going to be 4. Make sure you don't put negative 4, because remember your amplitude is always the absolute value of a. So put an absolute value around that first number right before your trig function, this trig function's cosine. That's going to be your amplitude. So amplitude is actually 4, so that means that we have vertical stretching since it's greater than 1. Now for our phase shift, you can write this. This might be the easier way to do this for phase shift. We know that this is the value c. We know that this is the value b. We know that the phase shift is c over b. I've already got a negative right there, so I don't have to do anything. We know that the phase shift is going to be positive since I already have that negative there. So that means we have pi over 5, which that is our phase shift. And because, okay, there's two ways to look at it. If I look at this function right here, and I see that I already have a negative, I would think I'd go to the left because it's negative, but since it's phase shift, it's opposite, so I go to the right. Or you can look at your result for phase shift and notice that it's positive, so that means I'm going to go or shift to the right. Okay. There's another way you could write. You could factor out the 5 and get this right here, and your phase shift would be right there, but this seems to be the easier way of doing it. Okay, now the period, since we said that b is 5, So period